have a background well in Pier Park. That well has had zero pressure. Yesterday it did have a slight positive pressure, but again, we think that was due to atmospheric pressure changes as the front came through. So the pressure data, it's complicated. It's not one size fits all, but we're working it, and I've worked on this stuff before. We just have to get enough data now to establish what's controlled by barometric pressure and what's controlled by potential gas migration. We have collected isotope or groundwater samples for isotope results. We're still waiting on those results, and we will be collecting gas samples for isotopic analysis over the next couple of weeks. I will tell you, I expect our initial gas results are probably going to come out being swamp gas, because the upper clay is full of swamp gas methane. And as the pressure increases below, even if the gas below is coming from deeper underground, it's got to displace all that swamp gas that's already there. So I fully expect our initial results to probably have a lot of swamp gas in them. This is the area where we have one type of indication or another of gas coming to the surface. We've combined everything. We've got hard data on. We have the bubble sites. We have vent wells up in here. We have our shallow geoprobe monitor wells. We've got the sinkhole. We've been back in the swamp, and you can see bubble areas. We've got gas coming up around an old water well down here. So what I did was just take everywhere we've got indications of gas coming to the surface, and this is not just a few bubbles. This is where we think it's a positive vent location where gas is coming up, and we outlined it in red. And so that's our first look at how far the gas may cover. If you look at this in relation to the top of the aquifer, one thing you'll notice, we have a lot of bubble sites in and around Bayou Corn where our vent wells are. That's near the structural high. This is the bottom of the clay, and it's kind of domed up, and that's where gas would tend to accumulate, and that's what we see happening. I honestly cannot explain what's going on over here in the Grand Bayou area. That's a question we've got. I don't have an answer for that. But these bubble sites and positive pressures and everything else match the geology very well. This is the conceptual model of the shallow gas migration. We have formation gas that's come up from way down there, 5,000–6,000 feet. It's accumulating in the sand and gravel aquifer. When it does that, it spreads out horizontally because the permeability is very high, so it can spread out. So we have formation gas, and this is what all the vent wells are installed in, is formation gas. The clay above that has a lot of fractures in it. It's not a uniform clay. It's a very typical southern Louisiana clay. We have fractures in it. The gas can move through those fractures, and it accumulates in these fine sands. We have these very thin sands on the order of 6 to 12 inches thick. They're very fine grain. We call them sugar sand because the grain size is about the size of grains of sugar. And the gas accumulates there, and we can install our geoprobes in these sands and get an idea of what the gas pressure is. And this example here, the gas pressure would be in a sand that's connected, and it's feeling the gas pressure. We have some of them that are like this. They're really not connected to the gas, and they tend to not show positive pressure in the gauges. And then, of course, everybody here is familiar with the gas coming up, gets in the sands below the bayous, and bubbles up through the bayous. So this, in terms of understanding the shallow gas, this is a simple conceptual model, but we're fairly comfortable that this is what's going on with all the data we've collected. The one thing I did mention, barometric pressure does change the pressures, especially in the 0 to a half a psi range, and we have to account for that when we do the final analysis. So just because you have a half psi on your property doesn't mean you necessarily have a gas flow from depth. This is what happens with houses. We have gas coming up through the aquifer, it's collecting. We've got a lot of indication it does move through the clay aquitard. You see it out in the bayous. That was the first indication it's coming through the clay, the bubbles in the bayous. Now we've put shallow probes in this clay aquitard, and in some places we're seeing positive pressure that indicates the gas may be migrating. Just like the bayous, the bubbles are not everywhere in the bayous. They're not all along all the bayous. They occur in distinct places. And that is exactly how it would manifest itself in the clay aquitard. So it doesn't mean it's coming up everywhere. It's coming up in spots. The problem is, on dry ground, it's virtually impossible to identify those locations. In the bayous and the swamp, it's really easy because you can see them. But in dry ground, it's virtually impossible to see where methane may be coming up. And what happens, what the risk is the gas comes through the clay aquitard and it can go through your floor slab. I know you look at your floor slab and say, oh, it's nice solid concrete. Gas can go through that concrete. It goes through utility openings. It goes through any cracks you've got in the concrete. It goes through any joints. People have studied this for years. Gas will go through concrete floor slabs. In fact, the permeability of a concrete floor slab, when they've done testing, is actually higher than the permeability of a fractured clay like we're dealing with. So it can get through. And what happens in enclosed spaces, not the whole house, I want to stress that. These are enclosed spaces like furnace rooms, hot water heater rooms, places where you don't normally live and you don't have ventilation. The gas can accumulate in those areas. And because they're not ventilated, it can keep accumulating until you reach a high enough concentration of methane that it causes a problem. And the ventilated areas where your air conditioning works and in the winter your heater works, those aren't the problem. It's the enclosed, unventilated spaces. If you have a slab or have a house built on piers, you don't have that problem because even a foot of airspace under your house, methane is very, very light. It's a very light gas. And what it'll do is come to the surface, and just natural air migration under your house will dilute it, and it won't be a problem. So, because we're dealing with very small amounts of gas, all right? The amount of gas coming through the clay aquitard. Can I get water? The amount of gas coming up, even where we have high pressure, is very, very small. But a very, very small amount can get in enclosed spaces and cause a problem. Under a house that's on piers, you don't have that problem. All right. I told you last time how I view this. So far, my 9 grandkids. I didn't show you the half a grandkid because she's not born yet. We have consulted an indoor air expert that we have retained. This is an expert shot he's done other jobs. We relayed this information to him with the pressures, and he confirmed, as I felt, that the methane pressures that we're seeing are right now a concern. Folks, I can't tell you enough, you need to get your houses inspected by DEP. gas accumulation in the homes. I can do calculations, I can wave my arms, I can draw pictures. You've got to get DEQ in your house so they can check them out to make sure there's not a problem.
All of those for the slabs.
Pardon?
All of the ones with the slabs.
Well, the ones with the slabs are the concern, okay? Those need to be checked. The problem is in the community, and I've been all over this community, if you have a house over here on a slab that isn't checked and there's gas accumulation, it can affect houses over here if something goes wrong. That's the way it works.
The one on the pillars don't have to be checked.
No, no. The one on pillars are fine.
But you can have.
Okay? Right now, we are working as hard as we can to get a better understanding of this. I will be the first to admit, I am hoping that we find out there's long-term, no real gas accumulation problem in the houses. I hope that more than anybody in this room does. But right now, I cannot make that assumption. The state has charged us, Shaw, with doing what's right to keep the people safe now and in the future. Right now, you need to get your homes checked, all right? That's the only way we can go in and make sure nothing's going wrong right now. The problem, and somebody's going to ask it, so I'm going to answer it ahead of time, is the conditions are changing out there. The sinkhole's changing, the gas is changing. So you get it checked today, that doesn't mean you can move back in tomorrow. And I'm sorry, but that's the way it is. That just means your home's safe today, all right?